video, we're going to talk about patterns in special products, specifically in the products of a plus b times a minus b, a plus b quantity squared, and a minus b quantity squared. So let's begin with our quantity a plus b times our quantity a minus b. So if we take this and we FOIL this, or distribute it, and we have a times a, so that would be a squared, and then a times negative b is a negative ab. B times a will give us a positive ab, and b times negative b will be a negative b squared. When we then combine our like terms, this will actually end up canceling each other out, so these will go away. They won't exist anymore. And so we're left with simply a squared minus b squared. Which means that if we were to have something like x plus 3 and x minus 3, we could essentially skip this step right here and just say, well, because it's written in the same form, we know the answer is going to be this first thing squared minus the second thing squared. So we could say x squared minus 3 squared, which is x squared minus 9, and we would be done. Let's take a look at the product of a plus b quantity squared. Now really what that's saying is a plus b times a plus b. So if we take that and we FOIL that, a times a is a squared, a times b is ab, and then b times a, which is a times b, and b times b is b squared. When we combine our like terms, that's going to give us an a squared plus 2ab plus b squared. So what that tells us is that if we have a plus b quantity squared, we can rewrite this. So if I had x plus 2 quantity squared, this would represent my a, and this would represent my b. So I could say x squared plus 2 times x plus 2 squared. And so that would give me an x squared plus 4x plus 4. And finally, let's look at our product for a minus b quantity squared. Just like the a plus b quantity squared, we would write this separately as a minus b times a minus b. We would then distribute, so a times a is a squared, a times negative b is negative ab, negative b times a is negative ab, and negative b times negative b is a positive b squared. When we combine our like terms, we're going to have an a squared minus 2ab plus b squared. So you can see that's very similar to what we got for the a plus b quantity squared, except this time it's got a minus 2ab in the middle instead of a plus. So what that means is that if I had x minus 4 quantity squared, I could write, so this would be my a and that would be my b, x squared minus, not plus, minus 2 times x times 4 plus 4 squared. So x squared, and negative 2 times 4 is a negative 8, so negative 8x plus 16. So if you can recognize these three pieces, the a plus b times a minus b, the a plus b quantity squared, and the a minus b quantity squared, instead of writing them all out or having to FOIL them out like we just did, you could kind of skip ahead and just follow the short of a squared minus b squared, of a squared plus 2 times a times b plus b squared, and a squared minus 2 times a times b plus b squared. Although when in doubt, you can always distribute and it will give you the same right answer. Let's practice finding the product of some of these. So here we want to find the product of a plus 3 quantity squared. And so remember, from above, that tells us that we would have a squared plus 2ab plus b squared, where this would be our a and this would be our b. So we can plug our pieces in, so a squared plus 2 times a times b plus b squared. So we can plug those in. So again, here's our a, there's our b, there's our b. And we can multiply those out. So I'm going to have a squared plus 2 times 3 is 6 times a plus 9. And we're done. And again, if I needed to, I always could have written a plus 3 times a plus 3, and I could have distributed and gotten the same answer. See, I'd have a squared plus 3a plus 3a plus 9, which is a squared plus 6a plus 9. So you'll get the same answer if you need to distribute to get your answers. Now for letter B, we have b minus 2 quantity squared, which means that matches our a squared minus 2 times a times b plus b squared. So we can set that up. This would be our a, and this would be our b. Okay, let me try using 2 different colors and see if that might help us a little bit. So if this is my a and this is my b, and I set it up, so I have a squared minus 2 times a times b plus b squared. So I put my a in the a spot, which is weird because it's the letter b, but that's okay. And then see, my b is the negative 2. So b squared is simply b squared, and negative 2 times negative 2 is a positive 4b, and then negative 2 squared is a positive 4. And it's written in standard form, and so that's going to be my final answer. Letter C says x minus 3 times x plus 3, and that's kind of like our first one, where it came out as a squared minus b squared. So we're going to let this be our a, and we're going to let 3 be our b. So we're going to have a squared minus b squared. So again, our a will go here, and our b will go here. So we're going to have, so we're going to have x there and 3 there. X squared is x squared, and 3 squared is 9. So x squared minus 9. And that's our final answer. Sometimes this is referred to as the difference of squares. Letter D is also like letter C, so I want you to try letter D on your own. Remember that it comes out to an a squared minus b squared. So go ahead and push pause and work this problem out, and then when you're done, push play, and let's see if you were right. So here we have 3x plus 1 times 3x minus 1. 3x will be my a, and 1 will be my b. So as I go to fill this out, I'll have a squared minus b squared. I'm going to put my a in the a spot and my b in the b spot. So I'm going to have 3x squared minus 1 squared. Now I'm going to need to distribute my squared to both the 3 and the x. And so that's going to give me a 3 squared times x squared minus 1 squared is 1. So when I work this out, 3 squared is a 9, x squared is x squared, and then minus 1. And I'm done. And so that is how you can use the special products to help you find the product of a polynomial.